Teja has been helping us out for many years. She's a data scientist and has spoken to us before last year.
Yeah, it's been a while, yeah.
And he also spoke at an IEEE event that I was running one of the tracks for last November. And he had the largest attendance of all the tracks that I was responsible for that day. So Teja is a very knowledgeable guy, so we're looking forward to hearing more about artificial intelligence and all the applications that you know about we can use for it. So have you, yeah, okay, got it.
I think we're good.
Thank you. Good morning, everyone. Good morning, everyone. My name is Teja, so I go by the name Teja. And firstly, I would like to thank Ed for giving this opportunity to use this platform. The hot topic today, the applications of AI, machine learning algorithms. A bit intro about myself. I'm an AI professional and a senior data scientist. So I did my master's in information systems, which is majors in data science and big data. Did my bachelor's in computer science engineering. I worked across the multiple domains like telecommunications, banking, insurance, healthcare, search engines, also the gaming applications. Suppose when I started my journey in a data science and big data style, there was not much data science around at the time, so there's no AI when I started my career. So I took that path because data is going to be growing soon. So lucky I'm here right now, which makes me have a lot of journey having AI stuff, which is a hot topic today. So lucky to be part of that. So I moved from 2019 from Sydney, Australia to here. So I started living in Dallas for almost like 4 years now. So we started liking this place because my son was born here. So even though it's pretty hot weather, so we like it. So, right. So get back to today. I'm going to present about the real-world applications of artificial intelligence, machine learning algorithms. I want to make it more interactive. This session is going to be. If you have any questions, you can stop it anytime and you can shoot a question to me. All right. The applications of AI in the real world. So we see the AI, right? So we see in a day-to-day life, AI was everywhere, right? We don't realize that AI was everywhere. So we can see a lot of applications in AI. I just listed out a few things, but even 10 slides is not enough to say what is the use of AI, right? AI was widespread across in all the domains. So you can see here, it was across the healthcare, social media, travel assistance, smart homes, automobile industry, banking sector. If you go to any kind of industry, AI was widely used. It was giving the more productivity. So that's the AI was emerging day by day. So few of the applications are listed here was about the fraud detection, chatbots, forecasting, self-driving, recommendations, and image classification, right? So we don't realize how the AI and how the AI was used in the day-to-day life, right? We go to the banking sector, right? A credit card transaction. If you have any fraudulent transactions, how this was picking up. So you're getting a message that you're swiping a message somewhere out of your country or somewhere, a transaction has been made, you get a message on your phone, right? You don't realize that how this was happened. The AI was the background on top of it. You're giving an alerting system if there's any fraudulent transactions happen, right? And if you go to interest of the IoT, so there's a lot of people around here was more interested in IoT. Even IoT was a beautiful thing which was happening, but even IoT with the AI, it makes it more robust and gives, if there's any kind of anomalies or anything, so AI can help the IoT to go help in more productivity. And coming to the security part too, so it was widely used across even the defense, the airplane sector, and all other sectors has been widely used. So it's not limited to one particular sector. Wherever there's a data there, you can use AI. So we'll jump into the AI. So what is an artificial intelligence? To understand how better we can use in the real world. So what is artificial intelligence? So I would like to ask you a question. So how do you feel? What is an AI? Can anyone say what is an AI? How do you feel AI is useful for you?
Algorithms that are working together.
So do you feel like it's a black box, or it does have any system in that? So everybody thinks that AI is a powerful tool, right? But what is background inside? Is there any magic happening inside? Yep, that's a great answer. But the AI, artificial intelligence, is a branch of merging the software, the technologies, and also a computer science and the mathematics. That's called as AI. So it's making a machine to mimic the human behavior of learning the patterns and then solving the hardware business problems. That's the AI. We got a big umbrella here. As you can see, artificial intelligence is the main branch, and we see a machine learning and deep learning, right? So we know what is artificial intelligence now. So what is a machine learning here? So machine learning is a branch belongs to the AI. It's a subset of AI. So it uses statistical methods like applying some mathematical algorithms to learn the patterns from existing data. So what kind of data it learns from the data and it used for a prediction to make the forecast or any kind of thing to be helping do the machine learning. So deep learning, one sector is deep learning. So deep learning is also a subset of the ML, and artificial intelligence is a bigger umbrella, and deep learning is sub part of the machine learning. So the difference between the machine learning and the deep learning is basically the deep learning is uses like a human brain, like you have a neural network connected. It has a back propagation, forward propagation, to learn the patterns of the data, and then it mimics and it produces the results out of it. That's the deep learning. So types of AI algorithms. So once you get familiar with these things, when we talk about the real, so we are talking about the real applications of the real world applications of AI. So why we need it? So I want to make this session to understand what basically AI and how the AI was useful in the real world applications. It's just not a black box. So what is it behind it, right? So we want to understand what are the different types of algorithms are there under the AI. So there are three types of algorithms are there. One is supervised and unsupervised, and the other is reinforcement learning. Can anyone guess what is supervised learning?
A person actually inputs data to correct them or pick out. I don't know.
It's kind of like gotcha.
Closed system, maybe inside if it's not out wild in the internet.
Not like our supervised manner, right? Supervised algorithms, right? So it's like a supervision, right? So you're giving an input. So you basically have an input and an output, right? So you're making a machine. So you're feeding an existing data. As I mentioned, if you have a data, if you have historical data, any kind of data, you can introduce an AI. Using a data, you can do anything, right? Supervised learning is one of the algorithms which we can apply on the existing data, which you have a labeled data, so which we call. You can see here, this is the training data. We have an ML algorithm, and we have an ML model here. You want to make a prediction. So you can see here, apple and banana. But you need to know the model should learn out of it, right? Whether it's an apple or a banana, that's we providing them as a label. That's called a supervised learning algorithm. So we do provide the machine to understand how to pick up it's a banana or an apple or any kind of classification you want to do. We are giving an output to train the model so that it learns the patterns out of it. So when we introduce a new kind of things for problem statement on the algorithm, which has already been trained, it's like a human nature, right? You already learned some things and you are using in a day-to-day life, right? You know how to drive a car. So you learn first you learn it and you start driving it. Similar way, the machine and algorithms also start teaching from the data using an output data. That's what we call supervised algorithm. You can see a formula here, right? Y is equal to f of x here. So basically, y is a target variable. So what is the target variable there? So the classification of the banana or apple. And the data was you feeding the training data there. So that's once the model has been trained and you feed and you introduce a new data, which is called test data, to see how your model is performing. That's called supervised learning. So can you guys know what is an unsupervised learning algorithm?
Somehow learn on its own. How would that work?
So
In some ways, it's structured versus unstructured data sets too.
yeah.
That's the big delta.
All right. So here's unsupervised learning algorithms, right? So as we go into supervised learning algorithms, the algorithms know what is the output. You know, it has learned from the pattern. When it goes to the unsupervised learning algorithm, it doesn't know. It doesn't even have any kind of output when it's training or something, right? It itself has to find that out. So what it does is it doesn't have a label data. You just feed the model with some inputs. It doesn't even have an output. it classifies them itself. So that's the unsupervised. The difference between supervised and unsupervised is supervised, we can measure the performance of a model. But coming to the unsupervised learning algorithms, we can't measure the performance there. But why we need unsupervised learning algorithms, right? In the real world, when we go into the things, we don't have a labels for all the things. We don't have a algorithm, right? Especially in the field of a fraudulent transaction to find out, you don't know what is a fraudulent transaction, right? But you want to understand how you want to detect in advance, we still want to use an AI to understand the new data points, which is a fraudulent transaction. So in that scenarios, unsupervised learning algorithms works better. So it basically starts training on the input data, but it doesn't have a label, but it classifies them into buckets. It's also we use in right across the different areas like customer segmentation, right? So if you want to run a specific offer, any campaign for any kind of a business model, you want to group all the similar kind of behaviors into one bucket. You can use the unsupervised learning algorithms.
So is there a risk of, if you take all these different variables that are just apparently have no relationship, like weather, temperature, person's height, inflation rate, and you throw it all into the black box and unsupervised learning, it's trying to find a pattern between all these unrelated variables. So you might force a relationship that may not exist, right?
And then you doesn't get a good pattern state, but you might end up in a different kind of buckets there, basically. So you have to classify them. Let's suppose if you have 3 different kinds of customers are there. So if you have a clear patterns, it can have a vision there, and it can cut into 3 different things. And also, it's not just like this is kind of like a mathematics involving the statistical learning, even unsupervised learning, when we have different algorithms like K-means algorithm and different algorithms are there. What basically it does is we have to feed the model with a K value that's coming from business knowledge, or even if you don't have a business knowledge, or how many number of segments you want to divide into, you basically use the statistical method where exactly the data is separating out between them. So that's where we run kind of statistical analysis on top of it, and we do provide the model that. So then it will bucket them into separate buckets. Okay, please go ahead.
So I heard a story the other day where AI companies are using annotation to classify various characteristics. In other words, they're using human capacity to say, oh, that's a duck, or that's a blue object. In other words, there's some behind the scenes things going on that give intelligence to the AI system through a series of human interaction.
Yes.
Is that true?
So that's one of the part of the supervised learning. Basically, you're feeding a prompt and also you're giving a response, right? That's what we're going to talk about the ChatGPT stuff. We'll have a lot of questions out there.
So human beings are actually being used to
Train
the model, yes.
AI.
Yeah. So you feed the model with kind of different kinds of data, right? So if you really want to understand, like I'm saying a hello, what is the next response is going to be? You give the prompt to that, and you make the models relate out of it. So once you type for a hello, then you get a message back to that. That's how the model has been trained on. But there's also unsupervised learning algorithms where you don't even have a label data. You don't know what's the prompt going to be.
Yeah.
But you still want to make some get out of the information. Like the super use case of that is like a anomaly detection, right? You don't know, because if you have a clean data and if you throw some rubbish data into that, but what unsupervised learning can do, it makes the separate bucket out, cleaning the data from the unclean data, right? So you have a separate bucket. It's very easy, right? If you have like billions of records there or billions of transactions of the data, especially the banking industry, you see a lot of customers around. So billions of records, million transactions a day, right? So they want to find out what is the fraudulent transaction, but it's really hard for them because they don't have each and every pattern already been trained into the model, but they still want to use the AI because if they want to keep a human around to check for each and every transaction, it's not going to happen. But they use the unsupervised learning algorithms. They can feed all the data into the unsupervised learning. But even though it's not everything is an anomaly, but everything, if it is falling apart from the regular patterns of the data, let's suppose if I'm using $100 a day, a maximum amount from last 2 years, but all of a sudden I started spending $1,000, automatically the unsupervised learning algorithm picks up that transaction. Hey, this is a fraudulent transaction anomaly. It sends out a message to my a mobile number, hey, can you confirm this is the transaction she made by you? You all see in the daily life, right? That's the unsupervised learning algorithms.
Like a $10 million transfer from Romania.
Yeah.
When you were doing 10,000 a week or so, right?
Yeah, something which is not your regular pattern, like far apart from that, because you're usually using in the United States. All of a sudden you went to a different country and started doing a transaction. But system understands that is unsupervised learning algorithm understands that, hey, something is going wrong here. Let's detect as an anomaly and we send out a message to the customer to confirm that, right? So that's kind of like a helping the banking industry to deal with the problem transaction.
But that's only the one approach. There's some other equations out there that take some different logic for unsupervised learning, because you mentioned like K values and solving. So there's some interesting unsupervised learning algorithms that are using some very unique logic, like solving for known nearest. So if it thinks it's relatively close, it'll go for it, which is why you see some things that error out. Like, is that a zebra or is it a horse? It kind of looks like a horse, or you'll get odd things depending on the equations, right?
Yeah. Right? You can use unlabeled data, you still interpret them out. So what basically this is puts into a bucket, like apples and oranges.
But if you throw a grapefruit in there,
it will put it in a separate bucket.
but sometimes it won't.
Sometimes it falls.
And that's because of the equations.
Yes,
right. Yeah.
But mostly if you have like a different kinds of algorithms, right? So if there is any noise involved in that, it mostly separates them out. So that's it. So I want to talk one algorithm at the end.
And I think that's where it gets interesting, is when it can't figure it out, right?
Yeah. It's always, there's no 100% right? So it's still trying to make it more perfect or optimal. So reinforcement learning, right? Reinforcement learning is other machine learning approach. It's like an agent, right? It's like a trial and error method. It learns from it, it makes the mistake, and it will learn from the back from it. It's like kind of a robot, right? You make the actions to be decided, and you experience from it, and you learn from it. It's kind of like a human learning, basically. So where are the areas we reinforcement learning uses, like the gaming sector, the recommendations? There's a few areas we use the reinforcement later. So we want to go into generative AI. So this is a pretty hot topic, right? So what is a generative AI? Any idea on generative AI?
Creates information, or in the case of ChatGPT, it creates a response to your request for analysis, or give me a report, or define something.
Yeah,
I like the idea of it.
Go ahead. Online.
I was gonna say oh, it's bad echo. Sorry. Finding a new thing between vectors. Right. The generating a text or image or audio from your words. The echo's kind of throwing me off. So I'll stop there.
All right. Generative AI is a type of artificial intelligence. You can see, right? It's a creation or a producing of the images, text, audio, and 3D models, right? So that's a generative AI. So it's the most popular things going on right now. So generative AI is capable of learning from existing data. So you feed a lot of data into that, kind of like a textual data, images, videos, audio, any kind of data you feed that, the model will learn out of it. And it also knows how to produce the images out of it, right? That's what we see every day. We are talking about a lot of generative AI stuff. We're talking about OpenAI. See how, if you're passing a text into that, you're getting a text data out, right? So if you're passing an image, but you want to know what is the image really mean for. If you pass them a laptop out, so you want to understand the information of a laptop. If you pass something about a country information, you want to know something about the country information, you send a flag out there, you will get what is the description of the country, how that is happening, right? So generative AI is the reason for that. So generative AI is basically a learning of the different kinds of data. It could be a textual data or audio or video, any kind of things. It mimics it learns from out of it, and it will produce a similar kind of the patterns to the data.
So at what point because in the recent 12 months, at least to me, generative AI, that has been something in the news and the stories and the industry. Whereas if you go back 3 years, we were just talking about machine learning and neural networks. So at what point in time did this, with ChatGPT, is that when this kind of came
Yeah.
to the forefront in the industry?
Last November.
Yeah.
So basically, generative AI was there for a while. It's not a pretty new thing. It was being there for generations. It's been coming for a while. But basically, generative AI is we don't have enough data to feed into things, right? So what they started, the open AI. So I'm going to talk about ChatGPT and existing stuff. So what basically they did, they have a bigger, large volumes of the systems which they can feed a large volumes of data across the globe. So that's where the model started learning about it. So when you go to the machine learning algorithms, so once we realize that data is producing some value to the organizations, people started collecting the data. When you go to the 10 years ago, 20 years ago, not many companies are collecting huge volumes of data. Right? They have a purging policy of 1 year or 2 years maximum. They purge the data. But once the companies start realizing that there's a value out of the data, so that's where the machine learning algorithms comes into picture, right? So machine learning algorithms, they started doing some value out of the data. They started storing for a while, and then so deep learning models need large volumes of data than a machine learning. Again, everybody started keeping the data. Data makes a value out of it. Once they start seeing the value, they went into the deep learning. Right? And once comes with generative AI, we are just limited with a data which is placed around with the numbers. Why not we play with the textual data or images and all these things? That's where the research was going in that direction because they have the data around. They started feeding in there. And they train the models in that way. That's where the generative AI started picking up the popularity.
If you're low, somewhat low tech on AI, like me, one of the things you just want to see it that you can do is go to the Bing search engine. They've incorporated, Microsoft's incorporated their AI and just mess around, without ChatGPT, subscription. It's kind of cool. You can put in, write me a story about fights off a, shoot out a 6-paragraph story and stuff like this. I mean, it's just kind of cool to mess around with if you're not wanting to.
And this is the scary stuff where the machines start to think for themselves, right? That's the Skynet, becoming a Skynet.
Yeah, so again, you take the good out of it, right? There's a pros and cons for every system there, right? So even the robotics startup when things comes up, pros and cons around. So but basically you start taking on what is good for you. And there's always a human intervention is needed, right? So we're going to talk about the strategy stuff. I'm going to talk about that part, what we're talking about scary part, right? So ChatGPT. So we have seen this from last year, it becomes a more popularity that everyone started ChatGPT. And there was a lot of questions in there. What is ChatGPT? And we trust the data in ChatGPT. Why ChatGPT, right? So anybody started using a ChatGPT here? So do you feel any difference in the way of working style or what kind of areas you started using with ChatGPT?
I use ChatGPT to respond to RFPs, and it does a really good job.
Okay, so what was that?
RFPs.
Well, I'm doing an RFP, right? So I use ChatGPT to basically get past my language barrier. Right? So I'll be lazy and go, well, I want ChatGPT to answer this question, so I'll type it in, and out it comes down. I don't think ChatGPT is actually thinking like a human. I think it's probably emulating human thought, right? Instead of actually having an IQ, I think it's more about taking a large segment of language, looking at that, and then basically coming back to me with whatever that response is.
Yeah. So but is it useful for you?
Yeah, it's great. And
Significant
we're also
productivity.
We're also using it to look at project management, scheduling, and like kind of pinpoint, optimal ways of scheduling a project.
Great. Anybody want to talk about how they're using a ChatGPT?
Yeah, just for me, looking for like code samples.
Exactly.
And we'll have this because you ask for a code sample of something, and in search results, it's typically something that's been searched a lot, which usually means it's over. So it's nice to get the result back and say, well, no, I don't want to use that library. I'd like to use this other library. And give it another chance. So usually within 2 or 3 times, it gives me a better answer that narrows down rather than just fishing around. So that's the.
I've had it write small code just looking up libraries saves hours of research, right?
You want to talk about it?
Yeah, I started interacting with the ChatGPT actually. Getting code, creating the content. These are all the things we can do it with ChatGPT. Apart from that, starts interacting with me like a human. You understand? It's taking my feedback. You understand? It's a way of how you prompt with the ChatGPT. You understand? Going forward, the prompt engine is creating a big picture in the artificial intelligence. So how we are interacting, and it starts interacting, it's taking my feedback. Based on my feedback also, it's taking the history. It's almost like a human interaction, you understand? That's what I was doing every day. Like, I'm using it for creating my code. I'm using it for creating my document. I'm using it for creating my feeds into LinkedIn. You understand? Like there are so many uses of ChatGPT. Like we have a Google bot. So there are different kinds of artificial intelligences right now. So yeah.
Thank you. Do you want to talk about it?
I just had one that the experience wasn't good, but I'm not a technical person. I was trying to do a agricultural drone brochure, and I did, cross-site studied everything, but the data in it was very inaccurate.
Okay.
I'm using it right now to help me determine where and how to modify the Unix kernel. So I've asked it to, with some variables that how I'd like to modify it.
Mhm.
I've asked it to go do, how would you do it?
Mhm.
And it's come back and it's given me some very great, fantastic ways to approach this concept, along with the fact that it says, here's some diagrams that you should probably have to help understand. But my question is, how do I take that definition of what the diagram should look like and get ChatGPT, because ChatGPT itself won't do it, but how do I get it to create that diagram? So I've got the complete explanation of what the diagram should look like. How do I get it to make the diagram?
Dolly and there's other AIs.
Yeah. I want to talk about that. We can solve the problem too. ChatGPT.
Yeah. The Unix kernel. Yeah, I want to get down to the bit flipping. I've got some ideas on how to enhance the Unix kernel. So I asked it I said, here's the concept, how would you do that? And it gave me some very good ways to do it. It's interesting.
All right. So let me talk about this. We hear a lot of positives and negatives here, right? So we'll see how the ChatGPT can be useful in our day-to-day life, right? Let's first understand what's the ChatGPT. So we know chat is just like basically like interacting with you, right? So anybody like a human interacting with you. It's similar to that. A system started interacting with a human because it was being trained in that way. So GPT. So what does GPT mean, right? A generative pre-trained transformer. So basically, it's a natural language processing tool which was being trained large, which is like it belongs to a category of large language models, right? So what is a ChatGPT? So ChatGPT is basically being trained with a lot of large language data across the globe, across the internet data, the books. It was taken from different places of the data. Large volumes of data was fed into the ChatGPT. It was being trained. So basically, whatever the ChatGPT they're using, it was until September 2021, I guess, it was being trained with the large volumes of data. Earlier, we were using a Google or any kind of Bing for a search engine if you want to look for any kind of things. But ChatGPT, is not just limited to just finding out something, right? So ChatGPT has been trained for if you want to find a code snippet of a Python, or it could be kind of looking for any kind of document you want to do, but any kind of things you want to do. It was being trained on internet data. But the question was, it's 100% accurate? No, because we have to have that kind of common sense to use this data, right? Because if you are a professional in that, it will help your life easier, but not 100% accurate. You can rely on that because it was being fed on a different kinds of data. Because so whatever the machine learning algorithms, I say the first thing why I talked about supervised and unsupervised is basically you're teaching your model or a system to learn the data from it. If you're giving an inaccurate information for a model to learn, obviously you're getting inaccurate information out of it. So it can be useful in our day-to-day lives. It's no harming that, but you should have your common sense to use the data. Kind of anything. Even if you want to make a code snippet, it will make you to create a function or any kind of things, a Python modules or something. Or you still need to be, you're putting into a production world, you need to be cautious, like whether it meets your requirement. It can be used as synthetical, because if you want to write like 100 lines of code, it might take you a day or two. But if you're using a ChatGPT, but you can just make a modification sort of, but you need to use your common sense, the language, things and everything. That's the ChatGPT. And so we have been using a natural language processing. So what is a natural language processing, right? So natural language processing is a field of a textual data, which we convert into a numbers basically to understand. So we were using this in the past to do kind of like sentimental analysis classification. But after the ChatGPT, the OpenAI, ChatGPT was developed by OpenAI. They started feeding all the language data. You kind of any code or any kind of things was being fed. Large data was being fed into the API.
So let me ask this question, because we had a discussion last night about this topic.
Mm-hmm.
When you write code using ChatGPT and you put that in production, do you owe somebody a license? Is there any, I mean, that code was generated by someone else effectively. So theoretically, do you owe, or do you need to refer, how do you keep yourself out of hot water if you go to market with code that was written by ChatGPT?
It's again standards, right? So you follow the traditional standard of the Python code or something. It could be any language code can use it, but it depends upon again. So you have to check with all the Latin stuff and everything. Anybody have a copyrights for it should be cautious about it. That's where the IP team and everything has to wonder about it. And you can't just simply use it and put it into a production.
But you can't tell where the copyright came from.
Right.
I mean, this is why a bunch of people are suing OpenAI, right? And saying, okay, you've taken my content in and I can get something that's clearly derived from it back out again. But you, the GPT user, can't tell. Right. So you don't know. And it's this whole legal limbo and what are we supposed to do?
We're going to talk about the risk about that. Yeah. So how do we deal with this, right? So this basically a ChatGPT is a large corpus of data, fitting to large language models, learns it from the data, from internet. So there is no reliability on the data, right? That's what the ChatGPT, but it has the benefits around it. You still can use it to make your life more easier. That's the ChatGPT for. So here are the different open AI models we have. So I want to talk about this chat, audio and video, and the codecs, right? So these are the training algorithms, open AI models, which ChatGPT is only textual kind of data. But this is open AI models. What we have, we can use it for chat, audio, video, and also the codecs and embeddings, right? So these are the different versions we have: the ChatGPT 3.5 version, 3 version, and the GPT-4 version. So GPT-4 version was the more advanced than the 3 versions. Whatever the mistakes it was doing, so there was a pro version there introduced into the market. I guess you might need to pay around $20 or something. So that has been a lot modified with the better than the 3 version. But if you are using a Bing AI or stuff, it's automatically integrated with that stuff, free chat on that. And audio and the video, right? These are the DALL-E models. These are proper algorithms you can use these things. To convert, it can generate the images from the text, basically. It was been fed in that way. And these are the codecs and embeddings. Basically, these are the few algorithms which are capable enough in producing the textual kind of things, embeddings, or similarities between the two texts. So now the question is, can we trust the ChatGPT, and how better we can use the ChatGPT? So ChatGPT is, or any kind of a large language models, because as I mentioned, any kind of data you feed into the model. So these are being trained well on a large volumes of the data. But if you want to make it to a production or any kind of things, you need to use a common sense. Plus, also you can retrain this model. You can use the model whatever it is trained for. Even you can use this model to retrain the model. You can enhance the model with your data. Suppose if you have your company organization's data, you want to make it fully robust or automatic things. You can retrain the model. You teach the model about it. Hey, you can take one of the OpenAI model, and these are the algorithms you have. You retrain the model with your requirements. You do the prompt, and you give the response out of it, and you make the model to layer out of it. That can be automated. That way, you have a confidence on your data.
Are all the millions of users that are using ChatGPT and providing feedback to it, in essence, are they training ChatGPT on their own, or is it isolated and input? When you say, oh, the code you gave me is incorrect, it should be, and you feed that back up into the model, are you effectively possibly changing the model? So if you had millions of people agreeing to feed it some bad information, could you affect the
Yes.
model?
But you're never gonna get people to coordinate like that.
Right, but that,
Well-
in theory, that could happen.
This gets
or-
to the social media problem with things that
Yes.
float to the top.
Yeah.
Yeah, but it's also just this massive network effect for OpenAI,
Uh-huh.
right? I mean, you can't replicate that data of people correcting. Nobody else is having their LLM corrected in quite the same volume that OpenAI is, right?
But again, so because you can't trust other people's data, right? If someone is feeding your data, you can't just trust it and use it in your organization, right? But that is what the things we do. Use this large language models. You can enhance it by yourself. You feed your own data itself. So you, rather than giving it feedback, if you really want to make it more robust with your organizational level, you can use the OpenAI model, plus you make it more robust by passing your responses in that.
Right.
You retrain the model, right? If somebody doesn't know how to drive it, you teach them how to drive it.
Just clarification, you're retraining only your portion of the model, not the model that's open to everybody.
Yes.
Well, it's taking the input from all the users, right, and
Well-
considering it.
Depends, right? If you're talking about ChatGPT, that all goes into the main thing, right?
Right.
If you are paying to train privately on your data, that's supposed to be owned by you.
Supposed to be owned,
Not
right.
supposed to, and I'm using supposed to, right?
Yeah.
Train the main mind. We know, you never know, right?
Yeah, your data and your model that you build, like with certain public cloud providers, do they learn from your input, or is it exclusive to you?
Right.
We're
Like
not quite to Skynet
The
yet,
legal
but
agreements
yeah.
say one thing, right? And we all wonder about the other.
Yeah.
So I could sabotage my competitors by
No.
putting false
No, you
information
can't.
out there.
Well, they take so much information from so many people. Like, it's not gonna happen. It's just a massive coordination problem.
I mean, we had the whole 1% text. So I don't think it's like that fixed. But
If you get enough people moving in the same direction, you could move the ocean possibly, right? So,
Yeah, but that's a concentration of usage that I don't know you can get with Chat. There's so many people playing around with ChatGPT now. Right? Like, how do you actually overwhelm the masses of people who are not coordinating with you to feed false information into it?
was everybody on
Well,
Yeah. Again, it's all about, right? You're driving on a road, so it's again a risk involved with that, right? You know how to make it yourself safe, right? So even you can use these models or any kind of things to make yourself robust. So you don't need to trust the data, but you can use these things to make your more productivity. That's the goal of any kind of AI, right? So there is no 100% accurate kind of models anywhere in this world.
But that's the happy path goal.
Yeah.
We're talking not happy path.
Yeah. The only thing is we take the phones out of it. Yeah.
so this is trust but verify, right?
Yeah.
Like it gives you output, but verify your output before you put it into.
That's a good way to put it.
Yeah.
That's a great way to put it.
Verify, yeah.
it's a good question because GPT-4 is notably better at math and logic. All those things that are not, because GPT-3 was like a pure LLM, it felt like, right?
Yes.
It's just pure word cell as a
GPT-4 can take the images as well. And it gives them.
But clearly they've done something with some kind of neurosymbolic AI.
They're feeding them more volumes of
Right? They've
data.
got something in there that's not just a language model, but they can actually do that logic and mathematics and
Yep.
whatnot. And somehow they glued it together.
Wow.
Like I said, it used to be you'd ask ChatGPT when in GPT-3 era, you'd ask it to do math and it would just get it wrong. It's just spitting out words. It's just guessing next words. Like what do I think the next word in this sentence is, right? And it can't really do math, right? But GPT-4 is different.
Yeah, that's the reason why they retrain the model with the large volumes of data again, right?
But it's also fundamentally a different
yes.
kind of model,
Yeah.
right?
So we talked about supervised and unsupervised, right? So because when we just take it from a large internet, they don't even know what is the label data. Because in fact, it's both supervised and unsupervised. Unsupervised, basically, you don't have a label data to learn the model. You don't know what to respond next, right? That's what it is happening. What is the drawbacks of these large language models is if they don't know anything which was not being learned in the past, they simply say, they don't know what to do. You can give it misinformation if it is closest to the information, but that's the common sense again. You have to use it in your daily life.
So you could run into that, like you ask it something obscure, I don't know, nuclear engineering related to whatever, some minute area of knowledge that it hasn't ingested any content on, you could get just
Those make shit
random nothingness, right?
Yeah.
It hallucinates.
Yeah.
That's what. Yeah.
Again, you can use those models. That's the, sorry,
Yeah, Finn, go ahead, Finn, Richard.
Oh yeah, no, I was gonna say there's a couple things in that. One, there's prompt engineering. Am I still too loud?
You're fine. Sorry about the echo. It's the room that causes this problem.
It's, yeah, there's no echo can on the bridge.
Okay, that's fine. Okay,
Sorry.
I'm gonna so
You can
when
always
I turn my own audio off. So the prompt engineering, which is interesting, if you ask the question, you can do something like there's a concept called tree of thought, and there's chain of thought, where because it's predicting that next token, if you get it to think out loud, it is a lot better at reasoning out through math problems and things like that. But there's also a recent leak of information about the details of GPT specifically, and how it's using, or potentially using, the rumors, according to the rumors, using this, I think was it mixture of experts or something, in up to 18 different neural networks. So depending on the question you ask, prompt you ask, it could hand off your prompt to different types of neural networks that all make up.
All right.
Again, so as you mentioned about GPT-4, so GPT-4 is basically, it's also connected to internet actually. It also collects the internet information, live internet. It's not just getting the back data, right? It also have the first data. That's called the big AI stuff. Okay, let's jump into the use cases with ML algorithms, right? Yeah, we talked about a lot about ChatGPT, supervised algorithms, unsupervised algorithms, whole bunch of things we talked about, right? We are talking about numbers, textual data, images, video, audio, right? So what do we understand from the standpoint of AI? If there is a data, we can use this AI in the real world, right? So that's what we can see here. So unsupervised, supervised, and reinforcement learning, right? So we can see unsupervised, we're using it as clustering. So what do we use the clustering for? We have a data for customer segmentation. So we want to group the similar behaviors of the into a one bucket. That's why we use customer segmentation with unsupervised learning. That's what we call clustering algorithms, right? Target marketing. If you want to market a specific offer to similar kind of behaviors, because if they are a loyal customers and if they're high value users and their behavior is in important way, the other users are just like they want to random things, right? You don't want to run the same kind of offer across all the users, right? But you have a data, but you want to utilize it in a way. How do you want to use it? You can use unsupervised learning algorithms. Recommendation systems. If you go anywhere into any kind of website, like Amazon, or it could be a Walmart, any kind of things, if you see a lot of recommendations happening. How it is happening? Recommendations is basically overlay the data from what you're clicking on that. It finds a similar item in there. That's what the unsupervised learning algorithm does that. So it will look about, there are different kinds of recommendation systems like collaborative filtering, content-based filtering. So even Netflix is that, right? You started liking a movie, action movie, and you'll do the recommendations, right? And also, if you are a similar kind of user who's also watching another movie, it also recommends that. That's called a hybrid model of recommendations. The whole bunch of stuff can be used with the data. So we can see a dimensionality reductions here. And when we go to supervised algorithms, we can do two different types of things. Supervised learning algorithm is basically you're feeding a model, you're constantly telling the model, hey, this is the data, you should learn from it, and you're giving an output. There won't be any kind of mistakes in there. You obviously feed the model with a good data, clean data there. That's what any organization started using. But LLMs become popular because they have all kinds of data. So classification is basically used in wide areas, right? You want to do a churn prediction model. You want to understand who are high likelihood to churn. So that kind of classification algorithms can be done. And even the image classification you do want to do. That's kind of classification algorithms you can do with the supervised learning algorithms. And the regression thing, this is a continuous variable. You want to understand what is the house value, or you want to keep a company to understand, hey, I want to give a special pricing for a customer based upon the behavior. That's kind of regression algorithm, regression things we deal with that. And also we can do the predictions based upon different kinds of features you feed to the model. You want to understand, like, so why there's the house price is more expensive here than the other area. If you look into the different kinds of data like demographics, it also sees about what is the annual income, these different features you feed into the model, you understand what is the value of it. The model will learn out of it. If you want to understand, if you want to predict the price of anywhere in the United States, it also has learned the patterns from it. You can do the predictions out of it. And you want to understand whether it's really a value to do it or not value to do it. That's where the model come into the picture. And you want to do the time series forecasting model, right? If you coming to the logistics space, you can see like let's giant companies like the Walmart or any kind of bigger companies. It's really hard for human mankind to monitor what is the stock needed for the next Christmas or something. Based upon the previous data, they understand the model should learn from it and it forecasts, hey, this much units you might need for the next Christmas or the new year. This is what your production is going to be. But it's every store is a different entity. That's where these models will learn the patterns out of it and will give the forecasting for it. And self-driving car. Today I was driving from my home to here. So my car has a robust features like you can do a self-driving kind of inside. So you also have these object detections. You wanna when you're moving out of this lane keep assistant. These are all the parts of the data science and AI. And even if you want to do the self-drive, so it knows how to attend, it will know how to stop it, and you can, that's called automatic cruise control. You use it in the day-to-day life. So everywhere when you see, even if you use a mobile phone, you see a facial recognition. That's the part of AI. It learns from your facial because whenever you started using a mobile, you register your facial patterns. So that system learns the patterns, and whenever you try to do it, it learns how to open it. And in the COVID time, we also see, right, when we use a mask, system doesn't understand, right? It doesn't know how to open it. What happened? Then Apple or any companies, what they do, they use a new patch on top of it. What is basically you just yourself with a mask, even it opens it. That's one of the retraining the model. That's the example of the retraining models.
I was going to say, how many models broke over the recent years, given COVID or these just crazy events like war in Ukraine affecting global markets? Like these models have never seen data like data sets like that, right? They've been trained on data prior to these kind of catastrophic events, right? So do data scientists kind of go through a whole retraining of models like when these type of things occur, or is there a whole thought process behind the world of AI and data science? It's like, okay, we got to be on the lookout for certain events that occur that just totally flip every single model on its side and like hit the pause button and retrain everything so we're not getting bad guidance and output.
I'll give you the real world application, right? So I started building a lot of models, like one of the use cases churn prediction model, right? So what we do, we started building a model, so the model was doing pretty decent job, accuracy is really good. We started marketing around the people who are high likelihood to churn with a specific offer, right? So they started taking the offer, they were returning well. But after a certain period of time, the new customers join, and you have different kinds of users being joined, right? And the patterns will be changed. The model which you trained was on a past data. It doesn't know the new patterns of the data. So you should have in a data science mode or an AI mode, we used to have that called model monitoring. So whenever we have the data, we run the model, we wait for the actual data come into the picture. We classify, we verify. That's what we call classification report, or we can report. We see how the model is performing on a day-to-day life. That's how. Then again, if there is a need in that, we again retrain the model with the new patterns of the data. It's always if any kind of new data is then you need to feed the model, right? That's the supervised learning algorithms. And especially if you're talking about a Ukraine war and all this, this was not done in the past. But if there was any kind of war happening in European countries like this, if the models have learned, it would have done predicted war. Or else it will use the near data to predict something, but it's still again a trade-off, right?
Right.
So
as an example to kind of dig a little deeper into what you were saying, so were you using like TensorFlow, or what kind of modeling tools were you using?
it depends, right? So sometimes you're building a neural networks model. Sometimes a XGBoost algorithm does better than a neural networks.
Okay.
Yeah, it depends upon the use case, how the model has been trained, what kind of parameters you've been. So machine learning algorithms is pretty much it's like a 4 lines of code, but the data, what data you're feeding into the model, that's the data science expertise comes into the picture, right?
But also, I've noticed that sometimes you have to use different equations occasionally because the model sometimes changes radically enough where you're having to use a different algorithm / equation.
That's what we do actually. Before we kind of, the model flow, it happens is that's the data collection, you start the first step, and you do the feature engineering. So feature engineering is basically you want to feed the model what kind of features you want to feed, right? And suppose if you want to predict a person who are highly likely to churn next month, you look at his journey from last 6 months. What is the sliding window of his behavior for 6 months? But ChatGPT or any LLMs can't even give this kind of things. Everybody was thinking, hey, ChatGPT or any kind of things came, it will take away everybody's jobs, right? It will only enable our life to make it easier, but it can't take anyone's job. So basically, you have to tell the model to learn out of it. Any kind of, I was building a gaming industry, one of the models we're building for that. We have only 2 features. One is grave frequency, and other one is game launch information. We don't have any kind of information outside of that. So if you feed that kind of things, you ask a ChatGPT for any kind of things to build a model, you won't even get anything out of it. We don't have a label data too. So, but you as a data scientist, you need to go into the shoes of the problem. You understand the problem statement. You understand what are the data you needed. You need to understand how you can better classify into a different features, and then you feed it to the model, and you get the output. Whatever you feed the input out, you get the output out. If you put the clean data, you get the clean output there. If you put rubbish outcomes. That's the models in the picture there. Yeah. This is about how you learn, right? If you take a good, you become a good person, right? If you take bad, you will end up in a evil. That's how it is. The way how you use the models, how you want to classify the models, how you want to introduce into your industry is the main question about how you want to think about it. That's the, again, there's always need to be the common sense to be used on these models.
Human involvement is never going to go away.
Never going to go.
Yeah. So
it will just enable the customer or any kind of humans. It will help the users to make it more productive. So we're talking about GitHub Copilot, right? It gives the code, it gives light of code. But if you want to introduce the same kind of code into any kind of your real property, you can't use it. But you can use the functions or anything, because if you have to rewrite the code or something, that's what we call code reusability, right? We don't need to write 200 lines of code again. But you can use that code, but you can modify it according to your needs, but you would have done it in 30 minutes. That's what the AI or any kind of thing is helping.
How much is the security of our information? That's what I'm worried.
So again, right? So we're going to talk about the risk with the ChatGPT LLMs, right?
Security and provenance of data.
So that's a great question. So especially the organizations level data, or let's suppose we talk about Amazon or any kind of things, or even any kind of social media things, right? So we have a privacy things because being typed, any kind of customer's data is not treated right. In any organization, I do work across multiple organizations. Any ID, even if as a data scientist, I wouldn't be able to find this was you. There was a lot of hashing of the happening as an ID, and you don't even know who that person is basically. You would only have a kind of like a hashing algorithm runs on top of it. You have a generative ID, and only you have data relevant to that person, but you don't know who that person is. That's called the PII information, that you maintain the security of things in organization. But coming to the LLMs again, if you put the security information into the internet, obviously LLMs will take it. This is all about you have to be common sense as a user, whether to put that kind of data into a social platform or not. As a person, you got to be cautious about it. Again, so there's again a risk with ChatGPT. As the lady mentioned about, she asked for a question and she gets inaccurate information, right? But all these LLM models, there's been tried built on the internet data, so nobody has the control on the data, like whether the data is correct or wrong. Again, you have to use your common sense to make sure whether you want to use it for your real purposes. That's the biggest risk with the ChatGPT or any kind of LLMs.
Yeah, I mean, today, if I use Bing in its standard form, I get a bunch of, responses. And I look at the first one and I say, that's too brief and sensible. The next one, that's way too detailed. I don't understand it. Third one, that looks like a reasonable answer. I'm doing that today. When I run Bing in generative mode, I get 3 paragraphs. I still need to apply some. I'm doing the same thing, right? The problem is if I read those 3 paragraphs and I say, I got what I need, man, this is great. And I don't think about it. But I'm doing that same process today, and it's actually
again, you need to have vigilance, right?
It's tedious today. And I'm on page 2 sometimes to find a reasonable search, there's a bunch of crap, beforehand. So still, I just still need to do the same thing.
So is it making your life easy? So I didn't quite catch your question.
No, it is making my life easier.
Yeah.
Yeah, for sure. But again, you need to not accept everything.
Yeah, obviously, right?
And like I said, I don't do that today.
A great point, actually. So, and again, coming to security threats, right? If you have any kind of PI information or any kind of things, right, the data has been filled in that. And if you use the data, let's say the threats is going to be like, so you don't know, right? You're gonna kind of put these models and use this data and you feed all your kind of PI information into that. There's a risk in all that, right? So you need to safeguard your data. So that's you have a security to your data point. That's what the problem with the ChatGPT or kind of LLMs is. There's no control on the data. They have getting the data from anywhere in the world. It could be a misleading information, right? It can somebody who trusts the ChatGPT and they put in the production because they want to make the cost cutting, right? If you are seeing a recession moment now, organizations start, hey, let's use the ChatGPT or LLMs, take away of the people who are really working hard, right? So we can do the cost cutting. There's a security threat involved in that. If they keep using this technology stuff without even a vigilance of any data scientist or any kind of a data person or any kind of software engineers. So if you simply put that into production, right, it can be a leading to security threat information, right? That's the technology is good for you as long as you use it in a better way.
So and we've kind of danced around it, but there's an issue with data provenance. So sometimes when the model brings in a piece of data, and sometimes when I do my prompt engineering, I ask cite your source. But the problem is that there's so much out there that it's not sourced or secondary sourced. So you don't know where the data is coming from that it's using to answer that. And then the other piece of provenance that's very problematic, some in text, but much more in generative art, is that it's taking people's copyrighted images. So that when you say generated Norman Rockwell painting of, a basset hound, which maybe Norman Rockwell never did a painting of a basset hound, it's using composites of other people's copyrighted material to create a generative new thing. This is what's causing a lot of issues.
Right.
It's like, I recognize that piece of is my copyrighted piece of my picture that you used in your generative picture. So this is another problem, is this data provenance and then the copyright issue that goes along with that, which is causing a lot of interesting questions right now, because you trained it with my stuff without my permission, right?
Again, you need to have a data governance on your stuff, right? Again, that's where the organizations are having a data governance. So you can't just simply use the data and then put it in production out. Hey, use this LLM everywhere, anywhere, right? It's not like that. You have to have vigilance.
DALL-E and the image generators are running into a world of problems because it's easily recognizable. Oh, that's my painting or that's my picture, right?
The biggest problem here is the validation, right? You don't know whether this data has been sourced from different kinds of sources. You don't know what sources.
Provenance. You don't know where it came from. Yeah.
But if you have your own data in your organization, you know the trust on the data. You're building from your own sources. So basically what I suggest is use any kind of this data to make your life more easy than putting that into as a game changer, right? Again, you have to use your common sense to make sure whether you can use it.
One thing, my understanding is Midjourney is now part of their contractual agreement. They're indemnifying being sued by. So they've put a stake in the ground saying that what they're doing.
And this is a really interesting thing because this is going to be battled out in courts, right? Yeah.
So they're betting the companies.
Who you mentioned doing that?
That's Midjourney. It's another tool.
It's an image generator.
Oh, okay.
Because this comes up pretty regularly on DALL-E and Midjourney.
Kind of image generation, right? So.
Because artists recognize, hey, that's my picture being reused. Right.
But what's to say if you go to a museum and you view a picture and you go and you're a talented artist, you go home and you create something in the same style? Is that?
Well, there's there's homage where you created it originally as an homage, and then there's directly using the painting to generate another painting, right? So that's where it gets a little more gray. But again, these are all shades of gray that we're talking about.
But again, if that was been already put into the model in the internet, that means someone should have already exposed that, right? So that's a security issue, you know.
Well, that was the interesting point where they're trying to indemnify against the copyright.
Is that, that's how Sheen is doing it. They're getting sued now by knocking off smaller designer fashion wear.
Right.
So there,
Sorry,
some companies are
too close.
finding that and creating it so quickly.
Again, so your kind of questions, like I understand that the problems around the picture generations, but why that must be better in the internet? Why there was not security around that?
Well, it was probably had a copyright, but if it's publicly
again,
available.
If something was been as a source to the ChatGPT or any kind of things, it was being exposed to the or everybody.
But it's not ingesting the copyrights nor protecting them that were on the original web page.
Yeah.
That's where I'm talking about the
That's
provenance.
where-
Yeah.
I know.
Yes.
Okay, so I'm going to talk about some interesting algorithms, right? So about the ML algorithms, how we can use it in our day-to-day life, right? So this is a random forest, one of the popular algorithms. So we can use it. So because we have a whole bunch of algorithms, it's going to be. And I'm going to talk about popular algorithm, which is random forest. This is a random forest algorithm is kind of like a algorithm which is used for both supervised algorithm, which is for both classification and regression problems. It is kind of like a decision trees. Is one of the algorithms. The number of decision trees has been built on a data set to give the final results. Basically, this do the averaging out of the messages. So you can see the multiple models have been built across. It will take the averaging or majority voting of the thing to get the final result. This is how the random forest must be built out. So if you are trying to approve a loan for a customer based upon his different kind of parameters, like his credit score, what is his income generation, and everything. So it takes different kinds of into the parameters or features into the model. It will give the result, and it will take the majority out of the different kind of models, and that gives the averaging out. That's how the random forest algorithm works out. Even if you are predicting something of the house price or anything, so this is how they take the mean value of the final results of different kinds of algorithms. So one of the other popular is DB scan. So we are talking about anomaly detection and all these things, right? This separation of the things. So DB scan is a density-based spatial clustering algorithms. Basically, it will try to find the noise in the data. So if any kind of noise, this belongs to a category of unsupervised learning algorithms. It doesn't have a label data. If you feed a volume of a data into that, if you feed noise into that, and you want to understand what is the noise out of it, and it will, whatever the load is, it is there. This is how it is, right? You can see some anomalies out of it here. The blue dots. That's how the model will predict into it as, hey, these are the anomalies. That's DB scan is famous for. So this is, so in the interest of IoT, a lot of people around here, it's IoT, right? So you want to understand, if you want to detect any kind of anomalies in the IoT devices or any kind of things, we can use unsupervised learning algorithms. Once you have a confidence in your data, you start collecting the data, you know what are the different kinds of anomalies, you identify as real anomalies, then you can start using supervised learning algorithms. But so what do we understand from this thing is, if you have a data, if you have a confidence in your data, you can start using AI there. Any source of data in your day-to-day life, any kind of use case, any kind of problem statement, we can solve with AI. Even in the healthcare, right? So there's a lot of things. So in the advanced cancer state, in a lot of things, they couldn't even recognize whether it's going to be leading an advanced stage. But AI is able to classify this or predict in advance this is going to be a tumor or something like that based on the X-rays.
So I did for UTD, we did with healthcare data, we used different model learnings, and the trick that we found was identifying which algorithm / methodology. So we went through so many different formula algorithms to find the one that worked best on the prediction. So you mentioned like one there, but we were looking at SVM models, Gaussian models, and we finally had to settle on a KNN model that worked. But it took so much testing of all the different models to see what produced the best results.
Yeah, you have to do that,
which is actually, I think, where people like you come in, the data scientist, and part of it is identifying which algorithms and how to use them, which is kind of the hard part. Like, which formulations and which models do you really use? Because there's new models all the time as well. like even we were looking at variations on these new algorithms to sit in. So, how are you picking some of these algorithms, and what's kind of your approach? Because that's a hard part.
It depends on the use case, right? Again, so.
But even if you have a defined use case, still knowing which algorithm
You
takes a lot of trial and error.
Definitely.
Yeah.
Basically, so you have to do the trial and error method. You understand which works better. You do the accuracy and all these things. You have to understand that. And again, as I mentioned,
And it takes time.
It takes some time, and also you need to clean the data in a way how the model can perform with good accuracy there. That also is a major part in there.
Well, I was assuming data had already been sanitized, but yeah.
Cool. So that's the part. Coming to the conclusion part, right? So we are talking a lot about the ChatGPT, textual data, kind of like statistical, supervised, unsupervised, lot of things, right? So we can use artificial intelligence. There's a potential to revolutionize anywhere in the industry. It could be any kind of industry. It could be even in a day-to-day life. We can use the AI in advanced stage to make our life more easier for us. Again, there are pros and cons around. So you have to take the good part around it, and we have to move and make the lives more better. Now that's how the technology was emerging. The change is needed for a life, right? Any kind of human beings. So that will help us to go further down. So that's the end of the presentation. And
Brian, did you have
thank
any
you.
questions?
Well, I did. So, this is an IoT session. So of the models you're talking about, what do you see being deployed directly at the edge using edge GPUs? What do you see staying in the cloud? Do you foresee any kind of hybrid scenarios?
So you're talking about IoT use cases?
Right. Or just, in general, right? We're all at the edge, right? That's
So TensorFlow Lite is what's being commonly used as the edge tool.
But do you see an LLM being fully deployed at the edge? Do you strictly see, someday, right? I mean, if we have
our MCUs at the edge and our CPUs at the edge are not usually that strong, but yeah.
No, but LLMs, they're working on reducing the number of parameters, right? So I'm wondering,
that's
5 years out.
TensorFlow Lite is the example of what you're talking about.
Yeah.
But
So again, so the deep learning models needs large volumes of data. I think it could be doesn't matter whatever it is.
Oh yeah, training, no question. Training has to stay in the cloud.
The training,
Once you've got the weights.
if you're building a model with 125 different columns a feature, the accuracy will be better for the 25 features, right? So so you need to understand what are the features being good for the model. That's how the statistical analysis you need to do. You need to do some correlation stuff, feature selection methods. That's the day-to-day life of a data scientist to understand that.
Yeah.
To solve the use cases.
To answer your question specifically, we've been able to stuff GPT-2 inside of mobile phones and get good performance for that model. GPT-3, even with quantization, stuff like that,
Right.
parameter space is just
Yeah. I know there's a lot of folks in the open source community trying to tighten up the parameter count.
Yeah, yeah. I mean, it's a whole area.
And maybe it's not LLMs, maybe it's the image stuff that belongs at the edge. That's why I asked the question, right?
even at the edge, the use cases commonly that I see are mostly for camera.
Yeah.
That's the ones I see the most. But if you look at other sensor data, usually TensorFlow Lite in a very small optimized model. And when I say small, I mean small.
Right. Yeah.
Or what's being commonly seen. But even then, a lot of times it's more effort than it's worth. Because on the edge, a lot of the data is very simplistic.
Yeah. If someone online would like to say something, go ahead.
Yeah.
Is that you, Ken?
Oh, this is Richard.
Okay.
I was going to say,
We're gonna close down for our official part of it. You're gonna be able to stay for a while, right? Yeah. Okay. One more question?
yeah, I was going to say,
Go ahead, online.
yeah. Where we work with, so at the company I work at now, Blues Inc., we do some stuff with machine learning at the edge, but it's a very small model. So we'll use like a company like Edge Impulse to build the model in the cloud, and the inference, the guessing what's happening could happen locally on a little device, like a little Arduino board even, but that model is created online and then shrunk down to a point where it can run locally. But it's really small stuff, right? It's looking at sensor data and doing something with it in the IoT space, but it's not an LLM, it's not an image classification system. It's not looking at video. It's very small stuff, like looking at a commercial cooler, for instance, and doing predictive maintenance, like should it, looking at the temperature and the vibration coming off the device, is that reaching a dangerous state? It can do that locally, but other more high-end stuff gets up to the cloud.
but not even like image classification locally. Where
Right.
You want to be able to do that not internet connected, or when you have when you need ultra low latency. It's not there yet. That's what I'm hearing.
ARM
Some-
shows stuff doing that, but it takes a little bit more processing power.
Yeah, you can do an
Yeah.
Even
ESP32.
in local, you can find the model. Like you can
Yeah.
use 600 of data.
And you might not do it on an Arduino. You might do it on a Jetson or something.
ESP32 with the camera can do a surprisingly amount of image classification
Yeah.
on the edge.
Yeah.
But it's doing very generic car versus person kind of things,
Yeah.
right?
Yeah.
Very
Edge
generic
being
model.
in the vehicle or near vehicle?
Yeah, it does very simplistic models.
But in vehicle.
In vehicle.
In vehicle. No, I'm saying on edge
Right.
in vehicle. Yeah.
Right.
Yeah.
But that's a good point, right? You might have local processing. Now that we have 5G, you might have something right there at a local tower versus way in the cloud versus on the vehicle.
Every light.
Architecting all that is wild.
So like you will see several vehicles now will have people detection on their cameras. So it'll do pedestrian person detection and blink up an indicator or say, hey, there's a person.
Yeah.
So, I mean, that's done on edge.
Right.
And that's
Right.
simple models. That's vehicle versus person kind of things, right?
Right.
All right, let's call it a.
What is the
Let's give TJ
Is it
Thank you very much.